Hello, any kids, parents, or adults out there that are willing to look at our post number two, getting fired up about math. We're going to do a little bit more with some number sense with multiplication. My name is Jim Mamer. I'm a former middle school math teacher and a current math coach for Hamilton City Schools.
Hi, I'm Jamie Cheney. I'm joining Mr. Mamer today. I'm a former middle school math teacher and now a current assistant principal in Hamilton, Ohio.
And we have come together because we both teach in the same district, and we got to work together as colleagues for a little over a year with math.
All right, everyone. Your challenge today is to figure out how many total dots you see in the picture below. The challenge is you cannot count each individual dot.
Love it. So before we get started, we're wanting to know if you'll pause the video because we're going to show at least 3 or 4 different examples after this pause. But we'd like you to pause and see if you could try to come up with at least one way, but maybe several ways that you see how many total dots are there. Thank you. Okay, Jamie, so I'm looking at all these dominoes, and one of the ways I'm seeing how we could do this is I see 9 dots on this first domino, and then I see I see 7 sets of dominoes here. So, or 7 dominoes. So I'm going to go over here and write 9 plus 9 plus 9 plus 9 plus 9 plus 9 plus 9 more. And then that would equal, I'm going to count them out, 9, 18, 27, 36, 45, 54, 63 total dots on those dominoes.
Well, Jim, I see you're thinking, and even a way to look at it or simplify it even more is since you are adding 9, 1, 2, 3, 4, 5, 6, 7 times, and again, you have 7 groups of 9, so you could write it as 7 times 9.
And we'd still get the same, so 7 groups of 9.
All right, Jim, so looking at the dominoes again in another way to see how many dots are on here, you can also look at the tops and the bottoms of the dominoes. So looking at the top, I have 4, 4, 4, 4, 4, and 4. 1, 2, 3, 4, 5, 6, 7. So I have 7 groups of 4, which is 28, and that's just for the top of the dominoes. But then I also have the bottoms. So I have 5, 5, 5, 5, 5, 5, and 5, which is again 7 groups of 5, which will give me 35. So combining those together gives me my 63.
Okay, Jamie, I got a couple things I'm going to share or talk about here. The 28 plus 35, I'm going to write that down again because being a math coach the last several years, I've got to go to a lot of elementary classrooms, and there's something I never thought about. I've just always carried the 1 because that's what we're told to do, and I just memorized it. But there's this, I was wondering if you'd ever seen this before. You could look at 8 plus 5 and say that that's 13 and just write it down. And then there's that 2 here, but it's actually 20. Because it's 2 10s, and this 3 that's actually 3 10s, which is actually 30. And we could say 20 plus 30. How much is 20 plus 30? Well, it just happens to be 50. And I can add these up. And it's really interesting that we still end up with that 63. Had you ever heard of that or seen that, Jamie?
I've never seen that before, but after you explain that, it makes a lot of sense.
It's really kind of neat. So it's kind of neat what the elementary teachers are doing. So we're going to go. I wanted to talk a little bit more, too, about the work that you did right over here. I like to try to notate this in another way. It's still going to be equivalent. So we saw you had said 7 groups of 4, and we had 7 groups of 5. And then you said you wanted to add those together to get the total dots. So I was wondering if it's okay, if you mind if I write it horizontally like that, and it's still going to give us the same answer. Still 7 groups of 4 plus 7 groups of 5. It should still be 63.
All right, Jim. So what I also noticed while you were working that out and looking at what I pointed out before, on each domino, we have a group of 4 and a group of 5. So if we combine those together, That gives us our 9 total dots on the domino. And then we also have 7 groups or 7 dominoes of the 4 plus 5, which equals 63. Because, again, we have 7 groups of 4 plus 5, or the quantity of 4 plus 5, which is 9, and 7 times 9 is 63.
So Jamie, this is all making me think about a property we've talked about in a prior video, the distributive property. So when we first looked at these dominoes and we first tried to do it on the other page, we had said that one way to get our answer was to do 7 times 9. And what's kind of neat here is our writing, the stuff that we've written up here, this 7 times 9, which we know was 63, you have taken the 9, you looked at a domino, and you looked at the domino as 4 dots. A domino is 4 dots plus 5 dots, which gives us those 9. So when you wrote your sentence, you're kind of taking the number 9 and breaking it apart into 2 different numbers, 4 plus 5. And the distributive property allows us to do that. We can rename 7 times 9 as 7 times the quantity of 4 plus 5, and we can see it on the dominoes. Then my sentence that I wrote above that was another expression that's using the distributive property idea, that when you do 7 groups of 4 plus 5, you can actually do 7 groups of 4 and 7 groups of 5, and then add them together, which was my sentence.
So, Jim, another strategy I've seen students use and it's been really effective is working with more friendly numbers. Like we mentioned before, there is 9 dots on each domino. So what I've done is I've added 1 dot at the top of the domino to make 10 dots on each domino.
I see.
So what that gives me is 7 groups of 10, but then that'll give me 70. But what I have to do, since I added 7 extra dots total, I have to take that away at the end to get my 63.
Okay, Jamie, if it's okay, I'm going to try to rewrite this in another format that's going to kind of go with the slides we had earlier. You had the 7 groups of 10, and then you subtracted those 7 green dots there that you'd added on. But I'm going to say that we subtracted those 7 groups of 1 dot to each die, which is still the same sentence, or an equivalent sentence, and you still get the 63. And Jamie, do you know why I did that?
No, I'm kind of curious to see, or what you're thinking is why you're doing that.
Okay, great. So I was thinking that when you said that you added a dot to every die, so when you did, you had put 10 dots on each die, but you knew there was only supposed to be 9. So that means on each die you started with 10, but you had to take away 1 dot from that die. So now you have your 9 dots per die, and you still had 7 of those groups, which again has this beautiful thing going on again. Here's that darn expanded form of a number sentence and a factored form for a sentence, which is using that beautiful property called the distributive property, which we will show in tons and tons of our videos. Okay, Jamie, I can't thank you enough for being willing to do this video with me as we try to find ways to support our kids and our families as they try to help kids learn math. This has been really fun for me, and I love learning.
Jim, I really appreciate the opportunity of being on the video with you and talking math, and just hopefully getting a chance to not only extend our own thinking, but encouraging others to do the same.
Thank you, Jamie.
Thank you.